This video will focus on the Ready, Set, Go problems from Unit 7, Lesson 8. In the Ready section, you're defining the key features or characteristics of a quadratic function given in standard form and graphed. The domain is the set of all possible x values. In this example, the domain is from negative infinity to positive infinity, or all real numbers. The range is the set of all possible y values. In this example, the range is from negative infinity to 4, or y is less than or equal to 4. Notice that we have included a bracket after the 4 instead of the parentheses. Remember that the parentheses indicates that the value is not included in the set, whereas the bracket indicates that the value is included. The interval of increasing is the domain, or x values, of the function where its values are getting larger. In this example, the function is increasing from negative infinity to negative 1. The interval of decreasing is the domain, or x values, of the function where its value is getting smaller. In this example, the function is decreasing from negative 1 to infinity. The vertex is the minimum or maximum point of the function. It is also the point where the parabola changes direction. In this example, the maximum point is located at negative 1, 4. The x-intercepts are the points where the function touches or crosses the x-axis. In this example, they are points negative 3, 0 and 1, 0. The y-intercept is the point where the function touches or crosses the y-axis. In this example, it is the point 0, 3. The axis of symmetry is the vertical line that passes through the vertex and divides the parabola into two congruent halves. The x-coordinate of the vertex is the equation of the axis of symmetry. In this example, it is x equals 1. It is also the point where the function changes direction from increasing to decreasing. In the set section, you're using key features or characteristics to interpret a quadratic function in context. What ticket price should this production sell their tickets for if they want to make a maximum profit? We can see that the vertex, or maximum, is located at the point 5, 150, where the x-coordinate represents the ticket price and the y-coordinate represents the profit. Therefore, the maximum profit they can make is $150 when they charge $5 per ticket. At what ticket price would the tickets become too expensive, resulting in no profit? At $10 per ticket, the production will not make any profit. This is shown by the point 10, 0. What would be a practical domain of ticket prices that would result in a profit? The practical domain is the set of x values that makes sense in the given scenario. For this function, the domain is negative infinity to positive infinity. However, the practical domain, or the practical ticket prices for the given scenario, would be anywhere from 1 cent to $9.95 for the production to make a profit. The practical domain is 0, 10. Remember that the parentheses indicate that the values go up to, but do not include 0 and 10. In the Go section, you're solving systems of equations. Recall that we can solve systems of equations by substitution, elimination, or graphing. Let's look at it at an example. The perimeter of a rectangular wooden deck is 90 feet. The deck's length, L, is 5 feet less than 4 times its width, W. Find the dimensions of the deck. Using the formula for finding the perimeter of a rectangle, P equals 2 times the length plus 2 times the width, we can replace the perimeter P with its given value of 90 and the length L with its given value of 4W minus 5. Now that we have one variable, we can solve for the width W. First, using the distributive property, we simplify the first term. Next, we simplify again by combining the like terms. Finally, we will use inverse operations to divide both sides of the equation by 10. We now know that the width, W, of the deck is 10 feet. Once we substitute the value of 10 into the equation for the length, L equals 4W minus 5, we have L equals 4 times 10 minus 5. Using the order of operations, we can simplify and find that the length of the deck is 35 feet.